So hey guys, welcome back to my channel. So in today's video, we are going to train a model to predict whether a SMS belong to spam or ham. So what is spam and ham? Basically, spam is a SMS that is like fraudulent SMS that is bombarded to too many people. Okay, and ham is the genuine SMS. It may be from your friends, from your colleagues, or anyway, which anything which is not spam is ham. Okay. So now let's first see our data set, how it look likes, and then we will dig into the model training. Okay. So let's see our data set. So as you can see, it is having two columns, ham and the actual message. Okay, so first one is the class name, whether it's a ham or a spam, or second is the actual message, if you can see. Okay, and we have around 5570 rows. Okay, and two columns. So the size is 5070 into 2. Okay, so now let's go ahead and try to create a model using this data set. Okay, so firstly we will as of course we will import pandas and import our database. So we will store our database into a data frame, and I have named the data frame as docs. Okay, because it's a document. So okay, so what I'm doing, I'm reading the table or the database. Okay, so basically it's a table. Why? Because it's containing the data in the tabular format. So I have used the read table, and then I am passing the file name, and then I am saying header equal to none. So my database, if you can see, is not having any headers. So I have said header equal to none, and then manually I have given the column names. So in a list I have provided the name is equal to class and SMS, and I have given separator as comma. So here the separators are comma, so I have manually classified the separator as comma. So by default for table it's /t, but I have kept it as comma. Okay, so here you can see our data frame got printed. Now we will say how many values or how many rows belong to spam or how many rows belong to ham. So for that I am using the function value counts. So you can see there are 4823 ham messages and only 747 spam messages are there. So this data set is good for training? No, it's slightly imbalanced. Why? Because when we train our model, okay, so we will give the positives more and the negatives less. So our model will be not able to identify spam messages. The accuracy will be slightly may get affected because the chances are like spam rows are very less in compared to the ham. Okay, so let's go ahead and see the values of in the ham spam. So you can see ham is having again the same thing. Okay, now what we want to do, we want to print the percentage of the spam from the whole data set. So what I have did, I have taken a variable and we are putting the values of spam and ham in this, and we are simply calculating the percentage of that. Okay, so you can see spam percentage is only 13. So the class or the data set is slightly imbalanced, but we can still go ahead and train the model, so it's not so issue. Okay, now as per my previous video, we are labeling ham as 0 and spam as 1. And why it's necessary? If you remember, sklearns want data into integer format, so that's why we are mapping ham as 0 and spam as 1. You can do the vice versa. You can do ham 1 or spam 0. So it's totally depend on the business requirements. Okay. So now if I print the head, you can see the label. I have added a label column and the label are zeros for ham and 1 for spam. Okay. Now I am in X, I will put the SMS, actual SMS, and in Y I will put the label. What is the label of the SMS? Now let's go ahead and print the shape of this. And if you remember, our data set was having 5570 rows. So it's a 1D array. X and Y both are 1D array having a values of 500, 5070. Okay, now when we, as you already know, or we have already did it earlier also, when we train our model, we split our database into train and test data. So here I am like splitting my data into train and test, and I am choosing random state as 1. Okay, so let's go ahead and split our database. Now let's get print the head of this xtrain, and you can see it's get printed. So we are having some of the messages here. Okay, now why splitting is necessary, I have explained it earlier also, but for new subscribers, splitting is necessary because suppose we have 2000 rows of data. So on 1800 rows or on 1600 rows, I want to train my model, and on remaining 400 rows or 200 rows, I want to test my model. So it's always have a good practice to test your model on something on which you have not trained your model. So that will give a fair output to you. Okay. So now let's in my previous video I have also explained the bag of words, so I will not repeat this. We are just for now I will like we are just taking initializing the vector, and we are creating a compressed array of our xtrain. Okay, so let's run this, and you can see we have the bag of words created here. Okay, and we have created the array of xtrain and xtest. Now let's go ahead and train our model. So here I am using Bernoulli. So we have created a class object, and we are fitting our xtrain data and ytrain. And here you can notice here is two functions. Ypred class equal to bnb.predict. So what is difference between this predict and this predict probability? So the predict probability will give you values like 0.9798. The probability is in percentage. Okay, but the predict will give you the actual class like spam or ham. So if you want to set your manual cutoff and go and tune your like output, you can use predict probability. But if you are interested in the class name, you can use the predict. So I have like used the both weight just to demonstrate to you guys. Okay, and here what I am doing, I am printing the accuracy score. So the accuracy score is 97%, which is quite good. Our model is trained very well. Anything above 70% is acceptable, and here it's 97, so it's like too good for us. Okay, so here we are printing the confusion matrix. So for people who don't know what is a confusion matrix, so confusion matrix is a 2 into 2 matrix which store data in like the first, the 0 0 is true negative. Okay, so the actual value which was negative was correctly identified by model as negative. So suppose we are having a data of a diabetic patients. So if it has correctly identifies the person who is not diabetic as non-diabetic. Okay, so that is a true negative. And then we are interested in this, the true positive. So the actual yes is predicted by model as yes. So these are the true negative and the true positive value, and this one is false positive and this is false negative. Okay, so this is a confusion matrix. It's used to check the accuracy of a model. Okay, and let's go ahead and create some of the matrices like sensitivity and specificity. Uh, so what is sensitivity means basically, it stands for true positive rate. Okay, so the true positive rate, we can explain it as something like, you can say, predict a proportion of actual positive cases correctly identified by the model. Okay, so this is the sensitivity, and the formula of the sensitivity is true positive divided by false negative plus true positive. Okay, and the specificity is equal to true negative divided by flow true negative plus false positive. So this is true negative. Okay, what true negative means? The measure of the proportion of actual negative cases correctly identified by model. And if you print this percentage, it's basically 1%. So we are good with that also. And the then we are going to print like the precision of the matrix, which is 1.0, and let's print all of them together. Recall score is 8.4, which is quite good. F score is 91. Okay, now let you go ahead and print the ROC curve. So in my earlier videos I have printed the ROC curve. So let's go ahead and print the ROC curve, and you can see the graph is very well got printed. All of the data sets are hugging this point, so it's a pretty well ROC curve. Okay, so that's all for today. In my next video I will train the model using the multinomial classifier. Thanks for watching. Bye bye.